All right, y'all, welcome to homework video number 10. I thought it was my turn to start pulling some weight on this channel, so it's me, Miss Avra, instead of Miss Keys today. Sorry if you were expecting Miss Keys. Okay, I'm going to do the problem on the left-hand side. This one is first asking for our x-intercept, and this function has already been graphed for us. I know it's kind of hard to see here, but our x-intercept's where it crosses the x-axis, and this is at the point 1, 0. So my x-intercept is at the point 1, 0. For this problem, I end up having a vertical asymptote. My function gets really close to the y-axis, but never touches or crosses the y-axis. So my vertical asymptote is at x is equal to 0. Now finding the inverse of the equation above, it's referring to this equation above. I've got y equals log base 2 of x. Inverse, remember, means switch x and y. So I always draw blanks where x and y are first. So then it makes it a little easier to see when I switch them. So I end up with x is equal to log base 2 of y, switching my x and y values from above. Okay. From there, I am going to solve for y, or I'm going to get y by itself. And I'm going to use circle method to do that. Now this one's a little trickier. We're used to the equal sign being on the other side of the equation, but it's the same process where we always start with the base. So that ends up with 2. I go across the equal sign to the power of x, and I go back around the equal sign is equal to y. So I see that my inverse is 2 to the power of x is equal to y. Okay. Next, it says sketch the inverse in the coordinate plane above and label the y-intercept and the horizontal asymptote. Okay, well, I know that the inverse is this function, so if I wanted to, I could go to desmos.com/calculator and graph it from there, or I can think about what I know and what I know about inverses. If the x-intercept of my original function is 1, 0, the y-intercept of my inverse is going to be at 0, 1 because the x and y values switch. So I'm going to go ahead and plot that at 0, 1. It's about there. And if I know my asymptote for my function is that x is equal to 0, for my inverse function, my asymptote will be at y is equal to 0. Because those x and y values switch. Okay, we go from a vertical asymptote to a horizontal asymptote. So sketching a function, it's going to end up looking something like this. Notice that those functions reflect across the line. Y is equal to x. One more way proving that these are inverses of each other. Okay, the final part of this equation, or this practice, it says solve the equation when y is equal to 8. So again, going back to this equation up here, I've got y is equal to log base 2 of x. I want to solve for x when we've got a value for y. Okay, so I'm going to take 8 and plug it in for y. So 8 is equal to log base 2 of x. Again, I'm going to solve here using circle method. So I start at the base. I'll draw in my boxes just to illustrate this a little bit better. Start with 2. That goes in my first box. Across the equal sign is 8. Back around to the x. So then I can plug 2 to the power of 8 in my calculator. And when I do that, 2 to the power of 8 gives me 256, so my final answer here is x is equal to 256. Okay, and then this side is the U-try problem. We're going to do one of the ACT problems together. We'll do this one, and then that one, number 19, will be one you can do on your own. This one says the population of a particular town is modeled by the equation P equals 120,000 times 1.1 to the power of t. I know that's hard to read. Where t is the number of years after January 1st, 2011. Based on the model, which of the following numbers is closest to the population of the town on January 1st, 2013? Okay, well, I know that January 1st, 2013 is 2 years after January 1st, 2011. So I know my value for t is 2. So I could solve this, or I could just plug in 2 for t here. I suggest plugging in 2 for t because if we're talking about ACT, we want to do this as quickly as possible. So again, I'm going to input 2 for my value of t. So I'm going to plug 1200 times 1.1 to the power of 2. I'm going to plug that in my calculator. And when I do, times 1.1 to the power of 2, when I do, I get 145,200. So it says closest to, rounded, the closest is 145,000. Okay, so here we just have to know that t is equal to 2, and t means 2 years after 2011. Okay, that is front side of the homework. I'm going to go ahead and flip over to the back of the homework. Again, working on the homework video problems. Hopefully these first two are pretty straightforward. The second two require a little bit that we haven't got to yet, but we will go over more over it next class. So this first one says solve for 5x is equal to 9. Okay, I'm going to use inverse operations here, and I'll use circle method on our second problem so you can see kind of two different methods of doing these. So on this one, I have 5x, 5 to the power of x, excuse me, is equal to 9. In order to cancel out a base of 5, I have to use a logarithm with a base of 5. If I do log base 5 on this side of the equation, I have to do the exact same thing on the other side of the equation. So I'll end up with log base 5 of 5 to the power of x is equal to log base 5 of 9. Okay. Now on this side of the equation, log base 5 will cancel out with the base 5 attached to my unknown exponent. So these will cancel, and I'm left with x is equal to log base 5 of 9. I can leave the answer just like that, or I can plug that in my calculator, which is going to give me x is equal to 1.365. So we used inverse operations on this top one. We're going to use circle method on this next one. So here, I always draw in my boxes for my circle method first, so I make sure everything goes in the right spot. I always start with my base. Here I have base 5, so that goes in my first box, across the equal sign to 3, which becomes my exponent, and back around to 2x minus 1, which is now what the other side of my equation is equal to. Okay, so I'm going to plug 5 to the power of 3 in my calculator. Remember that really means 5 times 5 times 5, which is 125, is equal to 2x minus 1. Then I'm going to solve for x here, so add 1 on both sides of the equation. That gives me 126 is equal to 2x. Divide by 2, and I know I'm running out of room here. So then I plug 126 divided by 2 in my calculator, and I get x is equal to 63. Okay. Now on these two, these are both ones that we haven't gone over yet, but I'm going to go over these on the video, and you should be able to solve your corresponding ones on the other side based on my example. Okay. So this one goes back to a rule. We're working on this problem here. Sorry, I've kind of written over it. This goes back to a rule that we learned during our solving game. I have a single base equal to the exact same base. Because it is base E and base E on both sides of the equation, those are equivalent, so I can essentially ignore them or cancel them out. So this becomes a far simpler problem without those base e's. Because I have base e on this side of the equation and base e on this side of the equation, a single base equal to a single base, I can cancel those out. From there, I'm just solving by combining my like terms. I'm going to subtract 4x on both sides first. That's going to give me 2x minus 9 is equal to 1. Add 9 on both sides. That'll give me 2x is equal to 10. Divide by 2 on both sides. X is equal to 5. So the key thing here is if I have a single base equal to the exact same base, I can cancel those out. They are equivalent expressions. Okay. The very last thing that I'm going to go over here is solving with our natural log. Now, solving with natural log, remember the definition we came up with for natural log before is natural log, I'll write it, where do I have room? I'll write it over here. Natural log is the same thing as log base e. Okay, these are equivalent expressions. So if you're like me and you like to use circle method, whenever I see natural log, I rewrite it as log base e of 2x minus 4 equals 6. Now this is a lot easier to solve with my circle method. So all I did here was use that natural log is the same thing as log base e, and I can solve with my circle method. Okay, so I set up my exponents, or set up my exponential form, so I can use circle method. I start with e, always start with my base, go across the equal sign to 6, and back around to 2x minus 4. And from here, I'm going to solve. I'm going to leave e to the 6th as e to the 6th because that's going to end up with kind of a funky decimal. So I'm going to start by adding 4 on both sides. So that gives me, I'm going to write this down here. Sorry, I'm just writing all over the place. E to the power of 6 plus 4 is equal to 2x. Then finally divide by 2 on both sides, divide by 2 on both sides. And I'm going to plug e to the power of 6 plus 4, all of that over 2, into my calculator exactly as it is written. So I'm going to set up my fraction bar first. And then E, reminder that your E button is on the left-hand side of your calculator, plus 4, all of that divided by 2. So you want to input it in your calculator just like that. Press enter, and I got 203.714 is equal to x. Okay. And that is everything for the homework video. I'm going to let you try these 2 ACT problems on your own. Yeah, that's all I got. No one's come up with a fun catchphrase for me to end this yet. Bonus points if you do. I'll end with like and subscribe. Bye.